So in previous module, we have seen previous video we have seen about the scratchpad memory, in which it will be having a multiplexer which helps in choosing the input data as well as the output data which need to be returned to the memory. And the location can be identified using the address, and from the memory, after performing the read or write operation, the read amount, that is from the memory, in order to fetch any data to perform the operation by the ALU, we perform the read operation, and read signal will be initiated to fetch the data from the scratchpad memory and place it on the registers A and B. So here we can see that when compared to the normal register transfer operations, data from the memory, that is during the register transfer operation, from the various registers, multiplexer was used to select the register to transfer the data to the A bus and B bus, from where the registers A and B will be loading the data. Here scratchpad memory, from the scratchpad memory, when the address is being given, based on the signal, that is read or write, and the data, if it is read, means the data will be available on a bus line which will be shared by both the registers A and B. Both the registers A and B will be sharing the common bus line. So how it will be taking, during the time some timing signal, the load will be initiated on the registers, respective registers, and based on that only, if a load is initiated on the register A, then it opens its latch and it will be able to fetch the data from the bus. Similar is the case with the register B also. Based on the load signal that is being initiated, it is allowed to fetch the data from the bus. And ALU performs the operation. Result will be stored on the shifter by moved to the bus, and the multiplexer, it again fetches the data and place it on the scratchpad memory based on the signals that is being initiated, that is a write signal, and to which location can be determined based on the address that is being given. So this is the process of a normal scratchpad memory, and here we have one more variant of this scratchpad memory, that is implemented using two ports. So saying similar to the other one, difference is like it makes use of two port, WE and ME. Okay. Also, there is no multiplexers. The output from ALU moved to the shifter, and then it will be moved to the scratchpad memory directly based on the address that is being given. And instead of read and write signals, what it is given here, it is WE and ME. ME and WE. W indicates the write enable. So here one more signal that is new to you is clock pulse. Okay, so during the, if that is a clock pulse, means like this it will, okay, this will be 1 and this will be 0, and when the clock signal is set to 1, and there is a clock pulse, if the clock pulse is set to 1, then the registers will be accepting new information from the memory. Okay, so when this clock pulse it is set to 1, it will be accepting new information from the memory. Similarly, clock pulse, if it is set to 0, then it disables. Okay, so it won't be accepting any data from the memory. This WE, write enable input. So during the clock input, there is a based on the clock pulse, read and write operations can be enabled or performed using this WE input. Okay, So based on this WEE input, you will be able to perform the read and write operations. Then, so here we are having two addresses there, A address and B address. Okay, so in previous case, what happened? Same bus line, only one address will be given, and data will be at a time only one register will be fetching the data. Anyone A or B will be fetching the data at a time. But in this case, it gives two addresses, A address and B address, which will be placed on the bus that is connected to A, and it will. So from this itself, we can understand that at a single point of time or at any clock's pulse, if CP is equal to 1, A and B will be able to accept the um, information from the scratchpad memory at the same time. Now, it won't wait for the other to complete its operation. So parallelly, it will be reading the data from the memory based on the address that is given in the port. So that is the two-port memory. Okay, two addresses will be specified so that the execution time can be reduced. Our timing signals will be reduced. Okay, so this is the difference between the scratchpad memory, a normal scratchpad memory and a two-port memory. The other things are same only. Okay, and one more thing, that is a memory enable. Memory enable, that is ME. The purpose of ME is like it helps in writing the data to the memory based on the address, that is the B address. So memory enable. When this ME signal is enabled, any new data can be written to the memory based on the address that is given in the port B address. Okay, so B address will be having some destination register. Okay. So the entire thing in this two-port memory will be classified, will be monitored based on the clock pulse that is being generated. So CP is equal to 1 means A and B will be able to fetch the data from the memory based on the addresses that is being given. And if ME is enabled means memory will be able to write the data or receive the data based on the address given in the port B. Okay, B address. Next is the accumulator register. Accumulator register. So these things, it comes under the processor organization. So accumulator register, here also we can explain it with the help of diagram. What is the purpose of accumulator register? For one address instructions, we make use of this accumulator register, isn't it? One operand will be the accumulator and the other operand will be the register or any other address. So it will be used only for a short period of time, and it can be considered to be as an intermediate storage of arithmetic and logic data in computer CPU. So for example, if you need to find the sum of two numbers that is stored in the processor register R1 and R2, what is the task to be performed? So first is like A will be initialized to 0, then content of R1 will be added to A, and current of R1 will be added to A and is replaced, replacing the previous content. So A will be replaced with the addition of A plus R1. Okay, so moving the content of R1 to A by performing that operation. And then again, during the timing variable T3, A is replaced with A plus R2. So A is having, currently A is having R1, which will be added with R2 to get the result. That is the addition of that two registers. So how it can be explained with the help of the diagram that you can see. So here arithmetic, again arithmetic operation is performed. So ALU will be there, and as said, accumulator register is also there. Then memory unit or the processor registers. Okay, for one address instruction means it can, the operand can be either the register or the memory. So if any input data um, is retrieved from outside means that input data shows over here. It will be given as input to these registers, or else the if it is accessing the memory unit, it need to know the B source. Okay, so you will be having some registers or memory unit. So in order to find the target location, it makes use of the select signal. Select B source. Okay, either to select the processor register or the memory based on the signal that is being given, it will be able to select the target uh, register, and that will be placed on the B bus, and that will be placed on the B bus. And ALU, it will be taking first, it will be initialized to 0. This A is initialized to 0. Then that A value will be given as an input to the accumulator value will be given as input to the ALU as the first operand. Then based on the signal that is given, it will be retrieving the information from processor register or memory cell and will be placed on B bus to get the data from the bus. If this ALU function select will be there, so based on that function, it retrieves the data from the bus, performs the operation, again shows a result to ALU. Output will be again fed to ALU. This is the process that is being done for any accumulator register. So this is a diagram for accumulator register. Next is the status register. So status register also we have learned in the first module, like it will be having a four forms like carry, um, carry, 0, S, and overflow. V indicates overflow. So it will be inside a register which is having 4 bit. Using these letters, it will be represented where C indicates carry, Z indicates 0, S indicates sign, and V indicates overflow. So what is the purpose of status register? In order to store this condition code flag bits, we make use of this status register. So this status register is used to monitor the results that is being obtained during the arithmetic operations. So for example, bit C, if it is set to 1 means the output carry of ALU will be equal to 1. So if there is any carry after performing the ALU operation, then C will be set to 1. And if bit S is set to 1 means the higher order bit or the most significant bit of the output will be 1. So in such cases, bit S is set to 1. Then if bit Z is set to 1 means after performing the ALU operation, the output obtained will be all zeros. So in that case, it indicates that the output is 0. So for that, Z will be set as 1. If bit V is set as 1, if there are two bits, like if the if okay, so in this ALU if the bit formed.